5p3. As the wire goes from vertical up to okay, so like this. We're gonna do three things: flux, EMF. Then we're gonna do the induced current. Sure, why not? Okay. Huh? Yeah. Over time. Thank you, Danielle. So, as this thing falls, what is the flux originally? Zero. And what is? Then it becomes max. Comes back to zero. I don't think that's too much of a stretch, is it? And now we say EMF is equal to negative n delta phi over delta t. Do you see that delta phi over delta t is the slope of this graph? Do you see that?
No.
Like, okay, so we've said delta phi over delta t is the slope, which is negative EMF. Let's just look at this equation and say, what is the slope here?
Zero.
Do you see? So it's going to be like that. And negative 0 is? Yeah, not too crazy there, okay? And then here, what is happening to the slope originally? So this is a positive slope, right? But
It's negative.
this says negative. Do you get that? And then do you see up here, this is some same value negative slope, but it's going to be positive.
Like inverse.
Yeah, so it's going to go something. And what is happening to the rate at which the slope is changing? Where does the slope change the most? Yeah, so it's going to be something like this. If I was drawing the slope of that curve, it would just be the opposite of this. That was terrible. Over R. So what does that do to each one of these values if you divide it by R? So you're just taking the green curve and dividing it by R. So like down here, I'm going to get some smaller negative value, aren't I? But 0 is still going to give you
Zero.
0. So it's going to be something like this. Now the trick is, you can come up with these numbers. So if you're actually doing this graph, you literally have to have numbers. Obviously, the curve doesn't have to be like perfect, but this value right here, this value, this value, this value, and that value have to have numbers. Do you get it?
So what would that
So if you should take a test, you have to find the value of the endpoints.
Yeah, you'd have to find the minimum, maximas, and all that junk. For example, here is what? Didn't it go from this to this in half a second?
Oh,
Wasn't there some time?
yeah.
So how long did it take to go all the way down?
0.5 seconds.
Oh, was it all the way down to half a second?
Yeah.
From vertical to vertical?
It fell
Time it
25.
takes to fall is, I don't know what that means.
Okay. If the drawing suggests all the way down, oh sorry, then that's 0.5 seconds. See, and then based on what was our maximum flux? We said it was something, right? 5 Tesla meters squared.
Yeah.
See what I'm saying here?
Yes.
And then what was our maximum current?
0.1 amps.
So this is 0.1 amps, negative 0.1 amps. You see what I'm saying there? You actually have to give these values. And what was the EMF? Was it 10 volts?
Yeah, it's 1.
It's 10 volts. A little note here. So this time should be 1 second. because we used 0.5 as going from vertical to horizontal. You get it?
Wait, explain that again.
It's because from the vertical up to the vertical